Yeah, I'm Tim. I'm on the community team. Specifically, I'm working just about full-time improving our community cookbooks. Like you may have seen today in the keynote, we shipped about 1,000. I think maybe like 800 of those were mine. So I've been a little busy, and I have some takeaways from that and kind of some ideas on how we can improve this and how we can do it better. And it all starts, of course, like with a little story. So we have an origin story of how we get started with a community cookbook. And it all starts with that meeting that you have, the mad dash from dev, ops, we need this MyFace app deployed tomorrow. You're holding up our business. We can't do anything until MyFace is deployed. And you say like, no worries, like I'm gonna whip this thing up in Chef, I got this. And also like, salt and straw is way expensive because that is $20 for ice cream. The end of the afternoon, 1.0 is done. And it's like simple and elegant, and it's everything you would expect it to be, right? It's this cookbook. We've all seen it either from our first day in the docs or our first day in training. We have a package of MyFace. We have a template for the MySpace config. And of course, like the only thing we would ever need to tune on MyFace is the port. Like, why would you ever change anything else? And then we have a service. We manage the service, we enable it, and we start it. And you're going like, my beard is a little itchy. I think I want to share this thing. I want to do the right thing, free as in beer or whatever. So you throw it up on GitHub, and you're like, cool, I'm done, right? Like, I'm a maintainer now. I'm going to walk away and do nothing. Like, mission accomplished. So some time goes by, and you get back to your normal job. You write, like, some other cookbooks that are equally kind of, like, simple yet awful. Maybe you put those on GitHub, too. And then one day you log into GitHub and you go like, oh shit, like people are using this thing. There's like 97 watchers and 518 stars. I'm not really sure what stars are for. Like I've started things, but I'm not really sure what I'm doing. Like, is it like a like? But then there's the last one, and that's the terrifying one. There's 372 forks. And you're like, MyFace was done. Why are people forking it? Like, it's code complete, it's perfect. Like, this is Nagios circa, like, 1999, right? So, like, clearly people need something that I didn't provide. And then you flip over and you're like, oh, like, also shit. Like, there's 48 PRs. Like, I should put my maintainer hat back on and do something about this, because clearly there's a need. So you start going through them, and, like, the first one comes in, and you're like, oh, yeah, like, this Red Hat Rocks person, they want like Red Hat support, and it's Red Hat, so like the package names are different, the service name's different. Like, that's cool, I'll merge that, right? There's a big green button. If they didn't want me to click it, they wouldn't make it green. And then like Java Ops comes in, because it's a Java app, like, which is a little scary, like, yeah, GC, heap size, all that stuff. Like, again, the button's green, I'm gonna merge it. Sure, like, what's a few more attributes? Oh, you want to change the instance name, like more attributes. Okay, yeah, that's cool, like that makes sense. Like, we're all making sense so far, but remember, there's 48 of them, so we're good. And like, things are gonna get weird. Like, really quick, like things are gonna get really weird. So you're gonna get this one, like Gen 2 support. Oh, all right, yeah, and it needs a 700-line library to work. And we have no tests, so like, maybe it works, maybe it doesn't. There's a good chance it doesn't. But you're like, somebody wants Gen 2 support, and I'm like open source, and I want to do the right thing, so like I'm going to merge this, right? So you click the green button again. And then this one comes in, you're like, wait a second. First of all, there's a Go port to this thing. I don't know why there's a Go port. And now it has a YAML config, and I need to write the cookbook to support both of these. But again, like, green button, so you merge it, and then the final one comes in, and you're like, a hash of arrays of hashes for the config. Like, I don't even understand why you would do that. Like, this just doesn't make sense. I'm not sure that data structure wasn't in my data structures class, so like, I don't know. But like, this guy says plus 100. And if there's a plus 100 on there, like, I better merge it, so I guess I'm gonna merge it. And at that moment, like, you just turned your cookbook into a complete tire fire. And like, over here is our database cookbook, which is currently still a complete tire fire. And you just ruined it. You ruined it with attributes, you ruined it with complexity. You took your simple, elegant version 1 cookbook and you just turned it into a mess. And chances are it now works for no one instead of working for everyone, which was your goal. And like, how do we fix this? How do we right this ship? Because we are heavily listing at this point. And we've done this a lot in Chef. We've had a lot of cookbooks where we got them to this point. We got them to this point not because we were bad, awful people, and not because the PRs that came in were also awful. Some of them, like, admittedly were, but that's a whole nother issue. We did it because we wanted to accept everything, and we never said no, and we just clicked that green merge button, and it was a time before testing, so the button was always green. And like, how do we fix that? And I think like kind of the cop-out answer is sort of that like we do need to scrap these and start over again. And you know, it really is a cop-out in all honesty, but like that's fine. And luckily we have a great example in our Tomcat cookbook. It is our My Face cookbook. It started out super elegant in 2009. I went back in history and found the very first commit and I read it and I was like, this is beautiful. Like, why could we not have stopped here? It had like 10 attributes and it installed on Ubuntu because that was like every chef cookbook ever at the time. And then we just started merging stuff and it's Tomcat, so it got bad pretty quick. But like quick sidebar, because I'm saying Tomcat. Like someone out here is like, oh man, like I know it was in the description, but like we're gonna talk about Tomcat a lot. I'm hearing Tomcat and like I hate Java. All the cool kids write everything in JS. So like that's fine, that's totally cool because like I'm here and that person's like over there or something and I'm just gonna say like something about Tomcat and you can just pretend that I'm saying something about Node and if like Node's not cool enough because that was like super last year, you can like say something about Rust because like all the cool stuff is written in Rust now. But my point is that like Tomcat doesn't matter. And the reason that Tomcat doesn't matter is because we're talking about the Tomcat cookbook and not Tomcat. I will give you my lesson of how Tomcat works. My small amount, this is my small amount of web operations here of Tomcat systems. Basically like someone writes some Java code of questionable quality and then you stick the world's largest server.xml config in and out comes like hopefully, you know, if you did it right, some web stuff that might be like an API or a WebSocket or like a cat GIF page or something. I don't know. So that's the end of the sidebar. It's like it was quick, legitimately quick. But why is this Tomcat cookbook such a great example of this life cycle? And it's not to say that like that's unique to Tomcat or even unique to the chef community because I've seen the same cookbook progression happen inside of businesses where you have a piece of cookbook that you start throwing out to other organizations and people use it and people contribute to make it work, you know, in a different org or a different business structure or whatever. And then next thing you know, like you have the same thing. And the real reason was like this Tomcat cookbook was just absolutely falling apart. I came to Chef about a year ago, almost 11 months ago. And there was 120 repositories and no one had been managing them for a while. It had definitely fallen into a state of disrepair. And the problem you get is like if you log into GitHub and you try to figure out what's going on to 120 repositories, there's just absolutely no way to do that. You have no way to figure out the state of 120 repositories. So I started playing around with the GitHub API and I started polling and I wanted to know like what was the repo with the most open PRs? What was the one with the most open issues? Like what was the one with the longest open issues? The longest open PRs, like the most forks, because you know that is a measure of like people thinking your work is incomplete. Also that they like it, which is you know good. Tomcat was number one on everything, and like that's not something you want to be number one on. Like we had like 50 open PRs at one point, and if you even wanted to start merging those, you couldn't, because by the time you get to the fourth one, you've made everyone have to rebase. So like that, you just can't even win at that point. And part of that was because we were trying to automate incredibly complex software. Like for anyone that has used Tomcat, like it kind of is that My Face app progression. Like it has every possible tunable knob. It has an enormous configuration file. It is, you know, it's an application server. It can do just about anything. And because of that, it's very hard to automate it in a way that makes any sense to people, specifically a simple way. We did it with a rigid monolithic design. We had a default.rb recipe. You apply default.rb, and that was what you got. We wrote an LWRP, but we just consumed that in our cookbook for some reason. I don't know why we did that. We had this cool thing that someone wrote, but like it was in the recipe and you had to use the recipe. So your destination was just controlled by like 100, 200, whatever, different crazy attribute knobs. And some of them like could only be turned on if other ones were on, and some of them were completely incompatible with other ones. And it was just that complete normal progression. Like we started with our awesome bike and we ended up with the Homer. And like that's not to say that any of the features on the Homer are bad, but like combined they're all awful. So it was like, we got to nuke this thing. We got to start over. But how do we do that? And I didn't want to do that. Like I wanted to think it through, because the reason that we wrote the original Tomcat cookbook and the reason it turned into that was because we didn't think it through. So I kind of came up with an idea to do a bit of a checklist. Some of it was a mental checklist and some of it was definitely written on like, how will we do this right? And it was these three questions. It's like, what does a community cookbook even look like? What is a community cookbook versus an in-house cookbook scope? Because we need to understand like how people are going to use it and why they might not just write their own. And then because we're going to do this thing resource-driven this time and not just have a default recipe, what are those building blocks even going to look like? So what is the job of a community cookbook anyways, which could have been the title of this talk. And I think it's this. So I think a community cookbook should provide simple interfaces to composable resources that empower users to write their own cookbooks, which aid in the automation of highly customized and complex software environments. And the whole thing is bolded because I'm going to go over all those bolded items. We'll skip the like 3 words in there in the middle. So simple interfaces. This is like probably the most important one. The reason someone is using your community cookbook is because it makes their life easier. If your interface is so complex and so hard to understand, if I have to like actually go learn how to use your cookbook, then it provides no value to me. And at that point, no one's going to use it. They're going to write their own. And as soon as everybody starts writing their own, then that provides no value to the community. So make a simple interface, figure out how to do it. If you can't do it, then maybe it's just not a thing for a cookbook. Composable resources. So we want to give people the tools to build what they need. We don't necessarily want to ship them a completed thing. This is different than some of the original ways we thought of chef cookbooks. Some of them were supposed to be these magical turnkey items. You would apply the default recipe and like, poof, chef would do your job for you. That was a lie, I'm sorry. Like, that was probably some way to get some VC funding in like 2009. We want to empower people to write their own cookbooks, and that kind of goes back to the fact that we're giving people tools. So I don't tell a person where this window goes or where this door goes, like they get to decide that. And I'm going to give them everything they need. I'll ship them a window, I'll ship them a door, but they can decide where it goes. And because of that, this thing that they build can fit into their complex software environment. And this is kind of another one of those unfortunate lies that we told. For a long time, people said, your environment is not a snowflake. Your environment is absolutely a snowflake. If it wasn't a snowflake, you'd be in someone else's business. Like, if what you're doing is so not unique, then you'll probably be out of business soon. Somebody's going to copy what you do. So that's the first item on our pre-rewrite checklist. Like, we actually understand what it means to be a community cookbook. What is the scope difference between a private cookbook and a community cookbook? And it's this thing, and I know like tables are kind of scary, but there's no good way to like put it in data. The first is the usage pattern. So your own cookbook is highly opinionated because it's for your business. It can be highly opinionated. The community cookbook has to be highly flexible. So if you're writing your business's cookbook for whatever and you try to just turn it around and put it into the community, it's not going to work. It will fail. Platform support, like generally you're writing a cookbook for the 1 or maybe 2 platforms you use. Like you're maybe a Linux shop, you're maybe a Windows shop, you're probably not both. Maybe you are, but you're probably not running the same application on both things. Whereas community cookbooks need to support everything. Like someone's going to want to run it on Gentoo. And as far as tunables go, like because your cookbook is highly opinionated, it only has a few tunables, and that's totally okay because you only need a few tunables. You don't need to make everything a knob if you don't have to tune it. The community cookbook, though, has to have everything because someone is going to want to tune every single thing. Their business will need whatever dial it is. So that's the scope. And then we can get to the cool stuff, which is like, what are the building blocks of this specific cookbook? Like, how do we figure out what we even need to build to make this thing right? And it all kind of goes back to that MyFace cookbook example, which I'm totally stealing this from Seth Fargo. If anybody doesn't know, like this is Seth Fargo's MyFace cookbook. We have three things here, right? We have this application binary that we're installing, the MyFace package. We have a MyFace config file, and we manage the service. And that is this, right? Like app binary config service management. It's a piece of cake, right? And the beauty is we can just map that. We can map that to the resources almost one-to-one. In most applications, when we're talking about a classic application, you're three things that you're concerned about. You're concerned about how to get the actual binary onto the server, how to configure it, and then how to make sure that it's up and running. So let's figure out what we even want this Tomcat install to look like. Because again, like we're not writing this thing right now. We're thinking through like what it's going to look like. So Tomcat install probably needs to like fetch the artifact. We'll worry about where that is later. Needs to like verify, that it's safe and whatnot. We want to be able to specify a version because somebody wants to install like Tomcat 6 and somebody wants maybe like 9. They want to do everything. We need to install it to a directory and we need to set some permissions on there. So we can get started. We can like generate our cookbook. This is the extent of the code writing here. Like boom, we've generated that. But even more importantly, we will generate our test cookbook. And the reason we're going to generate this test cookbook is the first thing we're going to do is just write the test. And the test is exactly the way the customer, that being the person you're giving this to, I mean, obviously they're not paying you for it, but like they're still your customer, the way they're going to use it. So I'm going to create Hello World. And we will test using the Hello World Tomcat app. So the very first thing somebody's going to need to do is make sure they have Java installed. Java's totally outside the scope of the Tomcat cookbook. It wasn't in the past, so that was a mistake. But we have a cool cookbook for that. It's a Java cookbook, so like use that. And then I'm going to use Tomcat install, Hello World. And like I said before, you'll be able to specify a version, an install path, and all this. The install path and whatnot will probably be defaults, but like I want to make sure it works, so I'm going to give non-default stuff here because we're writing a test. And then we have the Tomcat config. And this is kind of where like things stop, right? Because how do we write a simple interface for something that is an infinite number of variables in a crazy XML config? If you can think of some wonderful way to translate a really simple Ruby data structure into a crazy complex XML config, like that's great, do a PR, but I don't think it's possible. So I just didn't write it. And I think that's okay, because I think in reality, this is probably what somebody's going to do. It might not be cookbook file, it'll probably be template, but because they're using this within their business, they're probably going to have like 3 or 4 things that they tune. They're going to want in their dev environment maybe to use a different port. They're going to want to use less RAM, so they're going to have some GC settings and some heap size settings and things like that to tune. But the config will probably look the same. So it's much better for them, instead of making them put 99% of this code that they never actually tune into some funky data structure like a hash of arrays of hashes or whatever. Like instead of making the hash of arrays of hashes, just like say this isn't in the scope of this cookbook because it's not possible to easily automate it. So like boom, we're already done because we just wrote a third of it by skipping that. Now we can do Tomcat service instead. So Tomcat service, like it seems really simple, right? Like it's a service, but again, we are writing this for a number of different platforms. So when I say Tomcat service enable, it's not just starting the service. Like I have to make sure that I've landed the init script or the upstart config or the systemd config, and I need those different configs to run on every platform. And like good luck writing a sysv init script that works on like Debian and RHEL 5 and SUSE, because it's just not going to happen. It is possible, but it's just like not fun. So we'll define what that looks like, and it's going to be really classic, simple here. It looks kind of like Chef's service. So we're not going to make the person say like and use systemd. We're going to hide all that complexity from them because we're giving them a simple interface, and that's going to be our problem to worry about whether systemd should be used or not. So we put it all together and we end up with this. And this test recipe here would produce a working, really simple site. It would say hello world, and we can like point a test suite at it later, which we may do. And we would consider ourselves done. So like, how do we actually write this custom resource? We've written out what it would look like, but like that's obviously not custom resource code. And like, why is a custom resource even cool in the first place? Because a lot of people have probably written like LWRPs and like, oh, they were kind of cool, but I had to do like weird stuff and it didn't work all that great. So at its most basic, a custom resource is properties and actions. Properties are variables you pass in, and actions are what you want to do. So if we have Tomcat install, our action is install. If we have service, it's like stop, enable, whatever. But the thing that is really cool, I think, in custom resources is provides in the action class. So provides allows us to name the resource something that it isn't on disk. That might seem kind of weird, but I'll show you why it's cool later. And it also lets us specify the distros that we run it on, which is the most powerful thing in custom resources. And then the action class is just a really simple way to shove a bunch of methods into a place where everything runs in the context of the action, and you can write some code that isn't like top to bottom and horrible to read. So we'll create the resource here. A is my Atom alias, so this is just going to pop it up. I'll have my text editor now, and I can create this example properties. And this is Tomcat install. So I have a property name, and then we have a type, and then we have a few different things. So instance name is the first one here, and it's a string, and it's a special one. It's a name property, which means if somebody says Tomcat install hello world, instance name becomes hello world. Then we have version. It's a string again. We give it a default value. If somebody doesn't say what version of Tomcat they want, which they probably will, but if they don't for some reason, they're going to get 8036, which I just magically decided one day it was the current one, and that's the one you're getting. Exclude docs is a true or false item. So Tomcat ships with all of its docs in by default. I'm not sure why anybody would want it. That seems like a horrible security risk to me. So one of the things we can do here is, by default, delete them all. If for some reason you wanted the docs, you could not delete them. I don't know why you do that, but you could. And then the last three are kind of special ones. So we want to make some opinionated decisions here, but we also want to allow people to override them. So the opinionated decision that I make here is where we want to put the binary. We're fetching the binary not in package form. We're fetching it as a tarball off of Apache's website. So we have to stick it somewhere. So I'm going to stick it in op/tomcat _ the name of the instance. And that's because we could have like 6 instances running here, the way this cookbook is built. But we don't know the instance name at the beginning, so we have to lazily evaluate that. So by doing these as lazy evaluations, we can use another one of these variables that's above, which is instance name, and we can build a user, a group, and an install path through that. Then we have our actions. So the action here is install. This is a really simple one. And inside of it, I just shove a bunch of chef resources. I could do more crazy complex stuff, but for the most part, most people will probably just shove a bunch of resources in there. Through the magic of custom resources, I could have more than one of these. I could have an uninstall resource. Install will be the first one in my list, and because it's the first one on the list, it's the default one. So if a person says Tomcat install and they don't specify an action, the first one's going to run. It's going to be an install. Then I have my action class. This code is tiny. That's fine. You don't actually have to read it. This is a really evil method that I wrote that goes and fetches a checksum off of Apache's site because we want to actually take the checksums that they publish and compare it against the tarball that we get. We're not going to trust necessarily what the web server tells us, and we don't want you to have to create a SHA-1 or a SHA-256 or whatever. And also, at a certain point, they switch from MD5 to SHA-1, so we have to handle both of those, which makes it even worse. But like, we don't want that straight interaction code, so we're going to shove it down the bottom. We're going to hide it away, and you'll still be able to read the action. And someone who's touching this code later on, because it's open source, probably won't ever touch that, so they won't break it. And then the final one I was saying was provides. And in this case, I'm looking at the Tomcat service. But I think that provides is really probably the most powerful thing in custom resources, and it's what allows us to create really, really powerful community cookbooks that we couldn't do with a classic monolithic recipe. So in this case, this is Tomcat Service Systemd. In this cookbook, I'm actually shipping 3 different custom resources for service. There's a Systemd one, there's an Upstart one, and there's a sysvinit one. They're totally different files, which makes them very small, super easy to read. There's definitely some duplicated code in there, but I'm fine with that because it makes it a lot easier to read and a lot easier to understand. This one will only fire if the user either references it as Tomcat Service Systemd completely, or if they just say Tomcat Service and they're on one of these systems, they'll get it. So we can have another similar file that's for Upstart and another similar file that's for sysv, and we can decide what platforms it becomes the Tomcat Service resource on. And by doing that, someone just calls Tomcat Service, and if they're on RHEL 6, they get sysv. If they're on Ubuntu 12.04 box, they're going to get Upstart. If they're like, I don't like Upstart, but I'm on Ubuntu 12.04, I really want to use sysv, then they can call that sysv one directly. This also allows them to migrate from one older platform to a newer platform without having to update their recipe. So if they go from a rel 5 box to a rel 7 box, it'll go from a sysv file into a systemd file, and they'll never know, and it will just work, which is, again, what we want, because we want simple interfaces. So here's the mapping that gets us. Again, it's just 3 files, and it gets us a pretty wide amount of platform support there. And that was one of the big problems this cookbook had, is it had a really hard time with platform support, and specifically with init scripts. And that's like completely magic. Like Provides is absolutely magic. It's awesome. Thanks for everybody that wrote it. It makes writing these things way easier. And then like platform support's done, except it's not, because we kind of forgot like that one that sort of matches this background. And I'm going to pull like a Joshua Timberman and just say like PRs are welcome on that. I'm not writing Windows support. I've done Windows stuff before. I surprisingly actually run Tomcat on Windows, and I don't want to do it. So that's like somebody else's job, and that's fine. But there's one more thing, right? Because we've written our resource at this point. You'll just assume that the week or two that I spent there happened, and the whole thing is written and done. It's beautiful and perfect. But how do I know that this thing actually works, right? Like, I wrote a test cookbook, and I could even execute that test cookbook, but like, what does that mean? So like, we need to test the thing. And I don't mean like, I need to try to install Tomcat and see if it works, which is the way we used to test Tomcat. Like, somebody fired it up in VirtualBox and went like, oh, it seems to work. It's fine. Let's ship it. We need to actually have like real tests we're running. So the first one is cook style. And if you're not familiar with cook style is basically Rubocop. Like, not basically, like, it is totally Rubocop. Lamont over here wrote it. It's just a wrapper around Rubocop. Some other people too, apparently. Fletcher did it too, okay. Multiple people have done it. So we take a rubocop.yaml file that seems to make sense, and it is totally like my opinion of what a Rubocop file should look like, how you should use your quotes, like where you should not use hash rockets or whatever. We wrap that up and we put it into a command that's just called cook style, and we ship it so you don't have to worry about Rubocop. If you don't agree with our style, which is quite likely, you can just use Rubocop and you can make your own file, or you can have like your corp style. It's very simple, and the thing is open source, and you can check out how we did it, but it makes it really easy to give this to a developer and say like, just run cook style against this new thing, and it'll match like our company's Ruby standards. Then we also use Food Critic. We just released Food Critic 7. It's awesome. It no longer supports Chef 0.7. If you're still on that, like, I'm really sorry. We got rid of support. But Food Critic allows us to do the same kind of linting, but specific to Chef. So if someone does like bad notification, or they forget a name in the metadata, or email in the metadata, or something that our community / people who usually work for Chef have decided is bad, Food Critic will alert. And it's really helpful to keep people kind of like on the right path. It's not perfect, but it's pretty good. And then the final one is inspect. So inspect is probably like the most important one here. The other ones are getting you linting. You could have a cookbook that passes all the Rubocop stuff, it passes all the Food Critic stuff, but it could still like not work. Like, it could just be 100% broken. But if we write some nice integration tests for it, we can actually prove that it does work. And we have that test cookbook, and it's like a legit test cookbook because we started this whole process writing that as our design method. So this is a simplified version of the inspect test, and it's probably a little hard for some people to read, but like basically what we're doing here is we're just saying like, A, did the thing install? Like, is this file that comes in the installation even there? So my actual Tomcat install methods worked. Are the users in the groups there? Is the service started? And then really like the most important one, and honestly it could be the only one that we do, we would be totally set with this, is just, can I curl the page? Like, if I can curl that sample web page and get back the hello world string, then this entire thing worked, and this cookbook is functional on that platform that I'm testing. So we need to put it all together. We need to like wrap some nice test kitchen around this thing and make this all work so we can make sure we test our stuff. So locally, we can use Vagrant, and we can have a file that looks something like this. We're, again, testing on a lot of platforms because we support a lot of platforms. And if we do something weird, if we produce a bad upstart config, or we produce a bad sysv config, or somebody does a PR to like make something work better, we'll see if that like breaks CentOS 5. And if they're messing with the sysv file, there's like a 99% chance they're gonna break CentOS 5. But that's only local, right? Like this isn't that helpful. If a person submits a PR, I want them to know it's broken as soon as it happens, because this isn't just my organization. This is a community that's working on this. And I also don't want to have to pull down every branch and test them before I merge them, because that would like just take way too long. I don't have that kind of time. And luckily, Sean O'Mara wrote Kitchen Docking, and you can wire that up with Travis CI, and you can just get this super awesome experience. So in the background there, you can see a whole bunch of greens, and the greens are everything passing. So we're doing full integration testing on all these different platforms. We're running through Hello World, and we actually have a few other tests. We try to set up the docs page and make sure that the docs load. And then we confirm. And that whole process, like installing 2 different Tomcat instances and making sure 2 can coexist, making sure they use, one can specify sysv, the other one can use whatever the native is, like hitting pretty much all the different dials that we have and all the different scenarios that somebody would use takes, 3.5 minutes. Like that's pretty solid, like that's manageable. And we can do that on all of these different platforms. So I would highly recommend that. If you're looking for a starter on that, if you check out this cookbook, you can steal our Travis file. You can steal our Kitchen Docking file. There's a little bit of funkiness you have to do because they're Docker images, so you have to like put some extra stuff on there to get the init scripts to even work, particularly on like SUSE and some other like a little more funky platforms. But to sum it up, like, in order to do this thing right, we basically need to start with a design first. And that's where I think like a lot of people go wrong with this. They just jump into like, I think I know how to solve this problem. I'm gonna start coding, I'm gonna open up my editor, and I'm gonna whip something up, right? And that is gonna fail. And it might even like partially succeed, but it won't be as good as if you sit down and actually think through like, what does somebody need for this to work? Like how would a person even use Tomcat? Like I went and bought the Tomcat book. And I'm like, I'm gonna go learn Tomcat. And it was awful. And I flipped through it and like got a mild understanding of like how somebody might use Tomcat, and then realized that I couldn't automate the config and it didn't matter. And then we're gonna write a test cookbook because we wanna make sure that we start with the way that the consumer of this cookbook would actually use it. And from there, we can actually start writing our resources. And then we're gonna have testing. And then it's hopefully like everything works, right? Like rinse, repeat with that testing, because guess what? Like day one, it's not all gonna be green. There's gonna be a ton of red in there. But eventually you get that thing green, you're like, this is the coolest thing ever. Like I just got this thing installing on like 12 platforms. And that's it. And I think the last thing that I would say is like, I just covered an absolute sliver of custom resources. There's all kinds of crazy, cool, weird, funky things you can do in there, and a bunch of stuff that like I don't really use, and I'm not entirely sure why you would, but like somebody is like, that is so cool. And it's on our docs, and our docs site for custom resources is actually really solid. If you check it out, it has examples of how somebody would use it, and then it breaks out like all the things like the action class and provides, and like you can get a real understanding. It's not like a normal doc site. It's like really solid. And our docs folks are really responsive. So if there's something that's like seems a little fishy in there, you can email docs, and like they're pretty good. And that's all I have. So if anybody has any questions.
So when you ask a question, wait till the microphone comes to you so we can get on the recording.
Yeah, so were there a lot of chef internals that were written to be able to do custom resources? And if so, which version?
Yeah, I probably should have mentioned that. So custom resources came out in 12.5, and we then have a cookbook called Compat Resource. And Compat Resource like basically is us effectively shipping a monkey patch of our own application, which sounds a little dirty, and it is a little bit, but like I think you can monkey patch your own stuff. Like that's okay, just don't monkey patch other people's stuff. So we ship the current custom resource code back to the old chef, and that gets you compatibility from 12.0 on. Realistically, probably works well in 12.1. 12.0 is a little sketchy. So yeah, if you're using 12.0, you can use custom resources. You just have to use Compat Resource Cookbook.
What are some other good examples of resource-driven cookbooks besides Tomcat that are out there to look at?
Yeah, so because people are generally using that Compat Resource Cookbook, you can actually go to the supermarket and you can search for compat resource, and then you can check things that depend on it. And you can get a nice list of like everyone that's written a backwards compatible, at least, custom resource cookbook. But I've been porting it to some other stuff after I did this one. This was kind of like the head scratch. Like, how would I do that? How do I get like the init scripts to work even, and getting a better understanding of like how you even write like a good upstart config, because I'd never done that. I started doing it to the Memcache cookbook, and Push Jobs has it. I think you'll see a lot more of it soon.
Because Java and OpenJDK and the Oracle are in play here, how do we handle the package versus tarball? There's a lot of complexity there.
Yeah, so like some of that is really just honestly punted into the fact that I'm saying use the Java cookbook. The thing I didn't show there is in my test recipe, I actually use the attribute that accepts the license and allows us to go download the Oracle JDK. But you could totally use OpenJDK. I mean, obviously matching the version of the JDK you need and how you get the JDK on there, like that does come into play with something like Tomcat, because certain Tomcat versions require certain Java versions. Like, and again, like this isn't just like a turnkey gonna work. Like you have to know like, oh, I'm running Tomcat 7, so I need like Java 7 or whatever. And you're gonna have to get it on there. Using that Java cookbook works pretty well though.
My organization generally agrees with your approach. The include recipe, though, for Java, do you have an opinion on the depth of inclusion of recipes? Because right now my organization is thinking we shouldn't even use include recipe. We should be completely resource-oriented, except to probably the role layer as far as putting a sequential list or deterministic list of recipes, so you know just by looking at the role what's included, and then everything down from there would be resources.
Yeah, I mean, the Java cookbook could totally be a resource. There could be like a Java install resource, but the Java install resource would probably look just like the default recipe in the Java cookbook. So I don't know if like someone taking the time to change that into like a resource would really get you anything. So setting a hard requirement like that of saying like no recipes, like in the end, you're kind of getting the same thing. And I get that to a certain extent. Like you don't want this crazy, crazy depth of like, where's my code going, because I'm floating all over into all these different recipes. I want to kind of look at it and think of it as building blocks. I would probably keep it to a minimal. Like in that, somebody can use the Java recipe, and then anything else, like, you know, they have to get the artifact. Let's be realistic, they're not pulling it off of an HTTP site. Like they're grabbing it out of like Artifactory or something. So there's another resource there you're gonna have to write to like grab it out of Artifactory or something. But that's probably the only resource, or sorry, probably the only recipe that you would use to do this whole thing. All right, well, cool, thanks for coming.